Good to see some students. I thought आप सब घर चले गए. किसी को डर नहीं लगा? It's raining too much. हाँ, सब आसपास. You all stay close by. Yes. Only two of you?
Yes.
Why so?
Examination of Kolar and Sarvaswani. But Sarvaswani has been examined.
Gotcha. All right. So we have to start a new topic today.
Yes.
Shall we begin with spectrum? All right, sure. Sure. Spectrum. So the first topic in spectrum is dispersion of light, which is caused due to deviation. Okay. So we're starting with spectrum. Which chapter is this?
6.
Chapter 6. First is deviation of light through prism. So this we have already discussed, right? When we talk about refraction of light passing through prism. Okay. So anybody remembers the ray diagram? How do we draw the ray diagram of prism? Right. So we mark the midpoint of face AB and the midpoint of face AC and draw normal. Right. So we'll draw normals here. Okay. Now the incident ray. So this is the point of incidence, the intersection of AB and normal. So that is the incident ray. Now, what is the original direction? This is the original direction, okay? Original direction. So where should it bend? Should it bend towards the base? Away from the normal, inside the prism, right?
Yes.
So it will bend towards the normal. So let's take the light parallel to BC. So this is a monochromatic ray, right? Monochromatic. Incident ray. What is monochromatic? Mono means single. Chroma means color. Okay? So light of single color. Light of single color. Color is represented by wavelength. Okay? What governs the color of light? Its wavelength. Right? So this is the incident ray. Now it will suffer deviation. So what is the first deviation here? This is the first deviation. Right? And we'll call it delta 1. What is the angle? delta 1. See the diagram in the textbook. Okay. Now at this normal, what will happen? It will go away from normal, right? So what is the original direction? So this is now delta 2. Okay. So what is the total angle of deviation? So this is the final emergent ray. So this is the original direction, incident ray. This is the emergent ray. Right. So you just extend it backward. Straight. Okay. So this angle is total deviation delta. Right. Now vertically opposite, this also should be, if this is delta 2, this is also delta 2. Correct? So this angle is delta 1, this angle is delta 2. And if you consider this triangle, let's call this as, so this is P, Q, R, S. Let's call this as T. So from triangle TQR, delta is equal to delta 1 plus delta 2. Correct? By exterior angle theorem. What is the exterior angle? Delta. It is equal to sum of interior opposite angle. Right? Therefore, total deviation is equal to delta 1 plus delta 2. So this ray suffers deviation twice, at the first phase and at the second phase. So this is the total deviation. Is this clear? Now, we know what are the factors on which deviation depends. Factors on which we have already covered, right? Angle of deviation depends. So what does it depend on? Angle of deviation depends on refractive index, right? But is refractive index changing? It is the same glass, right? It will depend on wavelength. Okay. So deviation will depend on wavelength, right? But it is inversely dependent on wavelength. Because if wavelength increases, what happens? When the wavelength increases, then the refractive index decreases. Okay? So there is an inverse relation, right? When the wavelength increases, refractive index decreases, therefore deviation also decreases. Got it? You know, na? Whenever, so there is an inverse relation between the wavelength or the color of the ray and the deviation. Okay? It also depends on temperature. So when the temperature increases, what happens? Refractive index decreases. So with rise in temperature, deviation will decrease. Okay? So for this chapter, the relation between color, that is wavelength, and deviation is discussed. So angle of deviation decreases with increase of wavelength of color of light. Okay? Now, in this different colors, which color has maximum wavelength? Red has maximum wavelength. which is equal to how much? 8000 angstrom. And violet has minimum wavelength, which is equal to 4000 angstrom. Everything else is in between. Okay. So, which ray will face maximum refractive index or maximum deviation? So, deviation will be maximum for violet color. Here the deviation will be minimum. So, red color. So, now if I replace this monochromatic ray with white light, now see what happens. Right? Now, if monochromatic ray is replaced with white light, right? So here the refractive index also is minimum, right? Here the refractive index will be maximum. That's why maximum deviation will be caused. Where the monochromatic ray is replaced with white light. Again, let us draw this ray diagram. What do we get? We have A, E, and C. Choose the midpoint again. So now we have a white light incident on this. Right? So now we don't need this normal. We have understood, right? What should happen? So we have a source of white light. So this is coming from a small opening. This is white light. There could be some bulb, so it will throw light in all directions. So we are keeping the bulb inside a something like this. Okay, so very small ray of white light is coming out. Okay, point. But what is observed is, the screen is kept over here. What is observed is, now we observe something like this. This was the original direction. Okay. Now when it comes out, it bends further away from the mark. Okay, so it deviated twice, one over here and one over here, like this. There are two deviations, one on the face AB, second on the face AC, right? And now on the screen, this is the screen, right? We see there is red color on top, there is violet color below, and all other colors are in between. So there are 7 lines. 7 bands of colors. Are you with me? So you have 7 bands of colors. Okay, so you'll have so many lines in between. Right? So this arrangement of colors, when a white light is made to go through the prism, so every color is facing different refractive index, right? Because of this, deviation is different for different color. When the wavelength is large, deviation will be less. So for red color, deviation is least. That's why red is on top. Red is bending the least. Therefore, it is on top. So why is red bending the least? Because its speed is maximum. Its velocity will be minimum. So which color will travel with the minimum speed? Violet. That's why it is bending the most. Jaldi speed से निकले फट से निकल जाएगा. It doesn't get chance to get bent more. The one which is traveling slow will bend next, right? Understood? So it is because the different colors of light travel with different speed. Okay? And the relation is governed by the wavelength. That's why we get the band of color. Okay? So this is called spectrum. So, and what is this splitting of colors called? The splitting of dispersion. Splitting of white light into its component colors. Right? After passing through prism, is called dispersion of light. Dispersion of light. Okay? This splitting of colors is called dispersion of light. Okay? And the arrangement of this color in decreasing order of wavelength. If you look from top to bottom, or increasing order of wavelength, if you look from bottom to top, is called spectrum. Okay? This band of color is called spectrum of the band of colors with your is called spectrum of white light. Right? Arranged in increasing order of wavelength. As you go from violet to red, increasing order of wavelength. Is it clear? So we have described what is spectrum, right? So since this spectrum is visible to us, it is also called as visible spectrum, right? Suppose you write down till here, then I will go further. It's stuffy. Can you feel suffocated? Bad order. खुला रखे हैं यार. बाहर का दरवाजा खोल दो. फ्रेश एसी आ रही है, फ्रेश हवा आएगी. You come without notebook? Why?
I've got chemistry.
You wrote chemistry. So you can write in that and clear that page. Because if you write it, okay, it gets stored in your head. Otherwise, it's like a movie watching experience. You watch the movie, go home, sleep, and it's gone. So memory retention is very less. And when you write it, it is hardwired in the brain. many students are absent today? 3 boys. 3 boys and 4 girls. 7. And how many are present?
3 girls.
6 are 50%. So this is a very small chapter. So there is a the portion from this chapter is reduced. Okay, so I think scattering is no more in portion. Is it taught in the school?
No.
So if you look at the latest syllabus on the ICSE website, so from this chapter they have cut down quite a few topics. Right. So it depends on temperature also, angle of incidence also, right? So, but we are not bothered about it. We are only interested in wavelength. It also depends on the angle of prism. So you can write it like this. This means refractive index. This is also dependent on angle of the prism. It depends on angle of incidence, right? Okay, so it depends on 1, 2, 3, 4 factors and temperature. And depends on, so inversely dependent on temperature. So this. Right. So 1, 2, 3, 4, 5 factors are mentioned, but we are interested only in the wavelength part to understand deviation. Okay. Ultimately, all will give the same result. Sorry. Where? वो जो नीचे क्लोज किया है डेल्टा, स्मॉल डेल्टा, which represents deviation. ठीक है? बड़ा डेल्टा कैसे लिखते हैं? डेल्टा is a Greek letter, okay? जो हम इंग्लिश में डी बोलते हैं ना, डी, ग्रीक में क्या बोलते हैं? This is capital delta, this is small delta. इंग्लिश में क्या लिखते हैं हम? वही ग्रीक में ये हो जाता है, ठीक है। तो ये हम यूज करते हैं डिफरेंस बिटवीन एनी टू क्वांटिटीज, और ये यूज करते हैं स्मॉल डिफरेंस। ओके, दिस इज बिग डिफरेंस, दिस इज स्मॉल डिफरेंस। डेल्टा स्मॉल डेल्टा। और यहाँ पे डेल्टा हम लोग यूज कर रहे हैं किसके लिए? डेविएशन के लिए। और ये क्या है? डेविएशन इज व्हाट? डेविएशन इज एंगल। ये छोटा सा एंगल है, ठीक है। ये सब चीजें समझनी जरूरी है। पूछने में हेजिटेट मत किया करो। आई एम नॉट योर स्कूल टीचर, ओके। सो यू आर हियर टू बेसिकली क्लियर योर डाउट्स। कोई भी क्वेश्चन हो पूछो, हाँ। डोंट थिंक कि गलत है सही है, हाँ। मेरे को इरिटेट करने के लिए मत करो। जनरली नहीं समझ आ रहा तो पूछो। इरिटेट तो तुम नहीं करोगे, है ना? नहीं करोगे ना? हो गया? तो यहाँ पे क्या होता है? नाउ इफ मोनोक्रोमेटिक रे इज रिप्लेस्ड विद व्हाइट लाइट, तो क्या होता है? वी गेट स्पेक्ट्रम, ठीक है। वी गेट स्पेक्ट्रम। ठीक है, जो कि क्या है? वेव की ऑर्डर। एक्सटीरियर एंगल थ्योरम सबको पता है ना? एवरीबॉडी नोज व्हाट इज एक्सटीरियर एंगल थ्योरम? नहीं ना? देखो क्या होता है एक्सटीरियर एंगल थ्योरम। क्या होता है? सपोज यू हैव एनी ट्रायंगल, लेट अस से यू हैव एनी ट्रायंगल एबीसी, ठीक है। तो ये एक्सटीरियर एंगल हुआ, बाहर का एंगल। एक्सटीरियर मतलब बाहर का एंगल, ठीक है। तो हाउ मच दिस एंगल विल बी इक्वल टू? दिस इज इक्वल टू सम ऑफ इंटीरियर ऑपोजिट एंगल, अंदर के ऑपोजिट एंगल। सो एंगल सी एंगल सी तो अंदर का हो गया, ए सी समझो दिस इज डी, सो एंगल ए सी डी इज इक्वल टू सम ऑफ एंगल ए प्लस एंगल बी, ये हो गया इंटीरियर होगा, ये तो पता है बाहर का एंगल कैसे, बिकॉज व्हाट इज दिस एंगल इक्वल टू, this angle is equal to 180 minus c, correct, because angle ACD is equal to 180 minus c minus angle c, correct, but what is 180, angle sum property, a plus angle b plus angle c और ये minus ये कट हो गया तो क्या हो गया, a plus b है, ये लो मैं किसको समझा रहा हूँ, चलिए I did not finish explanation, he was somewhere else. ठीक, समझ आ गया व्हाट इज एक्सटीरियर एंगल थ्योरम, पढ़ा है तुमने मैथ्स में, हाँ ऑनलाइन, ओ माय गॉड, तो ये प्रॉब्लम है यू नो, ऑनलाइन वाले बच्चे जो है ना थोड़ा सा तकलीफ आ रही है, जिसने पढ़ाई नहीं की है उसको तकलीफ आ रही है, लेकिन अब पढ़ो, इट्स ओके, घर जाके देखना व्हाट इज एक्सटीरियर एंगल थ्योरम, प्रॉमिस करो नेक्स्ट क्लास में बताना मेरे, ठीक है, बाकी किसी को नहीं पता है एक्सटीरियर एंगल थ्योरम, पूछ लो विदाउट एनी हेजिटेशन, बाकी सबको पता है, बस एंगल सम प्रॉपर्टी पता है ना, you know angle sum property, angle sum property, what is sum of all the angles inside a triangle, वो पता है ना, तो बस उसी से तो आया, लीनियर पेयर पता है, लीनियर पेयर on a straight line sum of both the angle will be 180, पता है ना, तो बस उसी से आएगा, चलो कैन आई इरेज द लेफ्ट साइड, सबने लिख लिया, ओके, तो ये बताओ how many of you know that why are you studying, do you know this answer, are you studying because parents will scold you, नहीं ना, so why are you studying,
better life,
better life,
whatever आराम से,
so why ये पता होना चाहिए, तो इंटरेस्टेड होते हैं, why are we studying, let the answers come from you, so the first answer I got is better life, better life, money, okay, and you said something when the class laughed, what was that, only money, so good wife or husband, these days wife need good husband, no more dependent on parents, right, so they will judge you पढ़ा लिखा है कि नहीं, ठीक है, getting good wife needs to be qualified better, likewise getting good husband also, wife has to be highly qualified now these days, ठीक है, so it is in your interest, right, parents starting इसलिए पढ़ रहे हैं तो वो गड़बड़ है, you are studying for yourself, so you should be motivated, so better life is the answer for everything, so you will grow up as informed citizens, so if you are informed citizens, right, you will be able to take decisions for yourself, you will take better decisions about everything, better decisions, right, So will be clear-headed. That is, you will not be confused. Okay, you'll have clear-headed means it includes clear perspective. All these things. You, in short, you become wise citizens. Then the evil forces which are ever present might make you corrupt, honest. Okay? So there is scope to deviate. Deviation. It's also in real life because these external forces are ever present. So you will be able to choose between right and wrong. If you are informed, you will know what is good for you, what is not good for you. How does physics come here? Huh? When you do physics and maths, you get a very clear working brain. You are not reading literature where you have to listen to the dream stories, right? Where you got to really work your brain a little extra. So clear-headed person, maths and physics, this is result-oriented. Result-oriented. Like tomorrow, you become a rich man. Now you decided your ordinary flat is not enough. I want to make a villa for myself. ठीक है? तो मैं क्या करूँगा? आर्किटेक्ट बुलाऊंगा. वो लोग मुझे प्रपोजल देंगे. ठीक है? फिर वो प्रपोजल में जो बोल रहा है और जो मुझे प्लान्स दे रहा है, I have to understand that. ठीक है ना? सबको घर, गाड़ी, हवाई जहाज, टेलीविजन, मोबाइल सब यूज कर रहे हैं. कहाँ से आ रहा है? फिजिक्स. इलेक्ट्रिसिटी के बगैर रह सकते हो क्या? नहीं ना? कभी इलेक्ट्रिकल इंजीनियर बन गए? फिजिक्स. अगर डॉक्टर बनना है तो ऐसा हाथ देख के तो दवाई नहीं दोगे. You will need medicine, you will need instrument. कहाँ बनता है? Physics. So there is a discipline called biophysics. So without physics, nothing is possible. Whether you want to become engineer, doctor, or even vice citizens, at least you have to understand physics to be able to use the gadgets. बाद में change हो जाएगा, ठीक है? So why I am saying this is you should know why are we studying, okay? Then अंदर से motivation आएगा. So this is like you don't study for this. This is a consequence. What is it? Means it is given. ये तो होगा ही. You don't study for this. Not anymore. Right? Old days में होता होगा. But this is just a consequence. You are studying for this. So that you are able to lead a better, clear life. That's it. And then depending upon your interest, you will do the specialization. Right? If you don't study well, you will also not know what are your interests. तुम्हारा brain है, लेकिन think नहीं करता. You are not independent. So biggest thing is you become independent. Would you like to be dependent or independent? Independent gives you freedom. So ultimately, we are informing ourselves to lead a free life, independent life. No baggages. ठीक है? इसके लिए पढ़ रहा हूँ. चलो. The moment you become dependent, somebody will rule over you. ठीक है ना? इसके लिए पढ़ रहा हूँ. So if the importance of education is understood, let's go back to education. Right? You want to make a note of it? Okay. Anyway, it's in the video. So this was some motivation lecture for why we should study. So after today, you will not study because you are scared of your parents. You are studying for yourself. पढ़ा क्या spectrum. Dispersion हो गया, spectrum हो गया. Now let us understand what is electromagnetic spectrum. Okay. So when you analyze the sunlight, okay, so it doesn't only have this visible part of the spectrum. There is a part of spectrum beyond the violet ray on both sides, right? Beyond the violet ray and beyond the red light. Okay, now see, look here. So electromagnetic spectrum consists of visible spectrum. It is in between. So basically, what is spectrum? I told you, it is the orderly arrangement of various frequencies or wavelength of rays or radiation, right? So this is nothing but radiation, right? This is nothing but radiation. Okay, light radiation, we say. All waves are under radiation, right? So some radiations are visible to us, like these colors, but there are certain radiations in the environment which are not visible to us. So they are called ultraviolet. Beyond violet is called ultraviolet. Violet. Spelling, just check the spelling. V-I-O, right? Violet or I-O? V-I-O. Okay. So ultraviolet, and this side is called infrared. Understood? So ultraviolet and infrared are non-visible. Okay. So the full electromagnetic spectrum consists of not only the visible spectrum. So visible spectrum is a very small part of the entire electromagnetic spectrum. So this is with your YOR. Okay. So this is called the visible spectrum. Okay. Now there are other spectrums. So here you have infrared. रेड के आगे क्या है? इंफ्रारेड. उसके आगे क्या है? माइक्रोवेव. हर्ड ऑफ माइक्रोवेव. उसके आगे क्या है? रेडियो वेव. Understood? All these radiations are invisible. ठीक है? So they are invisible spectrum. So this is visible, and these are all invisible. What is spectrum? Arrangement of radiations in increasing order of wavelength. Okay? Okay. So on the left side, the wavelength is less. As you go towards right, the wavelength is increasing. Okay? So wavelength is increasing. Right? Now what about before violet? Ultraviolet. Is it visible? Violet. Is it violet or violet? What funny language is English? If I had to write violet, absolutely clear phonetically and writing wise. Is it not violet? Is it violet, violet? Bachpan se they will tell you. That's why this French, they hate English because they say it's a funny language. But anyway, it is imposed on us, so we have to. Right? Okay, ultraviolet. And some characters are silent. Now that's rude. पढ़ो बच्चे लोग सर दुख जाएगा. Okay, you know this, huh? But then why it is put? Why not put? PUT but. Then PUT is put. Why not put? These kind of questions are asked, right? And we have no answer. Learn that way. चिल्लाते ना ऐसे टीचर लोग चिल्लाते ना डोंट आर्ग्यू बैक बेचारा बच्चा पूछ रहा है say that's how I learn children you have to also learn the same खत्म चिल्लाने क्या जरूरत say don't know okay ultraviolet so when you become teachers okay when you don't know anything just say don't know finish why do you yell at students what is his mistake he's just asking a question right of course not irritating question okay beyond this is X-ray X-rays then you have gamma rays okay so again all these rays are invisible okay so what you have to know is only these names that's it nothing else you have to know for this you have to know the wavelength value for red it is 8000 angstrom and for violet it is 4000 angstrom in nanometer you write it as 400 nanometer this will be 800 nanometer so is the wavelength increasing as you go from left to right so wavelength is least for gamma rays so least wavelength so I will say lambda is least what is wavelength lambda least or minimum on the left side and lambda is maximum on the right side so which radiation has maximum wavelength radio waves understood even within radio waves we have a range okay acha so spectrum is organized in the orderly increasing wavelength when you go from left to right and when you go from right to left what increases is frequency so frequency is maximum for gamma rays frequency is minimum for radio waves right and energy of the radiation depends on frequency high frequency means high energy low frequency means low energy okay so energy is maximum okay on the left side as you go from right to left energy of the wave increases is minimum understood because there is a formula E is equal to h nu nu is frequency have you heard about it yes h nu so nu is frequency so if frequency high energy high got it that's it so this is the entire electromagnetic spectrum and you have to remember it this way right now there are some common characteristics of electromagnetic radiations let's read that can I erase this part yes
Is that the arrangement of spectrum?
Yes, this is the arrangement of entire electromagnetic spectrum from here to this one. So the entire electromagnetic spectrum consists of visible spectrum also. These are all the rays coming from sun. Okay. So sun ray consists of all this.
So
but some of the rays. Huh?
Can we store the energy of gamma rays?
Store we use gamma rays for treating cancer. Like you have cells, no? The cancerous cells are destroyed. So gamma rays can penetrate inside your bones also, every part of your body. So there has to be a limited exposure to the patient, otherwise we will lose the patient. Okay, so chemotherapy etc. is done, right? So that is like radiation treatment, radiation therapy. So that's why we use gamma rays. Then we have ultraviolet rays, we use it for sterilization. So we will be studying, earlier there was full electromagnetic spectrum in your syllabus, but now we will be studying properties and uses of only ultraviolet and infrared rays. And we'll be studying the common properties of all the rays. Okay? Understood? Okay. So, common properties of electromagnetic spectrum or electromagnetic waves. So, all these are waves only, okay? Waves, right? Everything, light wave, it is called light wave. Okay, radiation is in the form of wave, right? Sound is a wave. Is it part of electromagnetic spectrum? No. Sound is a different type of a wave, right? It requires medium to travel. It is coming to your ear through air, reaching ear through air. If we are in vacuum, will you hear the sound? No. So sound is a different type of wave. Electromagnetic waves are different. They don't need medium to travel, right? So we'll write the common properties. EM waves do not require any medium to travel. Okay, yes, that's why from sun the light reaches us, so it travels through lot of space. Space has only vacuum. Our atmosphere is consisting of air, so it has a gaseous medium, but it crosses so much of distance in space and reaches Earth's surface. So EM waves do not require any medium. So all these waves, light wave, ultraviolet, they all can travel without medium. What if there is a medium? Can they not travel? They can. Light is traveling across the glass, so it can go through the medium also, right? But it does not need any medium for travel. Unlike sound waves. Second, speed with which all EM waves travel is same, which is 3 into 10 raised to 8 meter per second. It is the speed of light, right? Which is c, right? समझ आया? Speed of light c. सब ये सब वही स्पीड से चलते हैं. Whether it is radio wave, gamma ray, anything. ठीक है? So light में क्या होता है? Reflection, refraction होता है. वैसे ही सब waves में होता है. ठीक है? So all EM waves obey laws of reflection and refraction. जैसे लाइट वेव में हमने बहुत डिटेल में पढ़ा है, सेम इज ट्रू फॉर ऑल अदर वेव. सो लाइट में तो रिफ्लेक्शन दिखता है, इसमें वी विल हैव टू डिटेक्ट इनडायरेक्टली थ्रू सम अदर मेथड्स. ठीक है? So this is your properties of light. There are some more properties. But these are very common properties. So I think we'll stop after discussing the properties of. So EM waves are not reflected by electric and magnetic fields. Again, तीसरा EM waves are transverse waves. Transverse waves. Okay? Everybody understands the last 2 points? Transverse मालूम है? Okay, बता दो पहले लिख लो. नहीं तो next class में बताऊंगा. Ask me in the next class. और ये वाला पॉइंट भी समझ में आया क्या? EM waves are not reflected by electric and magnetic fields because they are chargeless. उसमें charge नहीं होता. Like electron and proton, they are positively or negative. But light wave के अंदर कोई charge particle नहीं होता. इसलिए it passes without deviation through electric and magnetic fields. Transverse में क्या होता है? देखो, any wave which is traveling like this, okay, but the particles of the medium are vibrating perpendicular to the direction of propagation. Then it is called transverse. Like string wave. अगर तुम्हारे पास एक रस्सी है, तुम उसको ऐसे प्लग करो. गिटार की स्ट्रिंग है. You plug it like this, so it vibrates like this. But whatever you have plugged here, that disturbance reaches to the other end also. So the wave or the disturbance is traveling horizontally, but the particles of the string are vibrating cross, which is called transverse. Unlike sound, में क्या होता है? When you are speaking, right, the air molecules are disturbed, oscillating like this, and the wave also, sound is also traveling horizontally. So that is longitudinal. Okay, so दो type का wave होता है, longitudinal और transverse. ठीक है? All right. So we'll stop here. See you in the next class.